Imagine just for a second, trying to get through your day without Wi-Fi. Seriously, no GPS yelling directions at you on a road trip, no Bluetooth syncing up your headphones, and absolutely zero smartphone notifications buzzing in your pocket. It sounds completely ancient, right? Well, the invisible web of communication that literally defines our modern civilization didn't just magically appear. It had to be discovered, calculated, and mathematically proven from scratch. Welcome to This Explainer. Today, we're diving deep into the incredible story of a quiet Scottish physicist who practically wrote the blueprint for our entire modern reality.
So, if I were to ask you right now, who actually invented the modern wireless world? Who is the real father of all this electrical wizardry? You'd probably shout out Thomas Edison, or maybe Nikola Tesla, right? And honestly, those are solid guesses, but the real answer? It's a name most people don't even know. A guy whose discoveries made literally everything Edison and Tesla did even possible.
We're talking about James Clerk Maxwell, and if you have any doubts about his absolute titan status in the world of physics, look no further than Albert Einstein. Einstein actually said, "The work of James Clerk Maxwell changed the world forever." In fact, he had such massive respect for the guy that he kept a framed portrait of Maxwell hanging right on his office wall, right up there next to Isaac Newton and Michael Faraday. So how exactly did a relatively unknown scientist earn a permanent spot on Einstein's wall?
Okay, let's set the scene here. It's the 1800s. Scientists are endlessly curious, and they figured out a few really cool things about nature. On one hand, you've got electricity. They played with static shocks, and Benjamin Franklin has already proven that lightning is just a giant electrical discharge. Then, on the other hand, you've got magnetism. They know certain rocks attract iron, and they've got compasses reliably pointing north. But here was the massive, glaring problem. These were completely separate, incredibly mysterious puzzle pieces. They had all these neat experiments, but absolutely zero underlying theory connecting them together.
Section 1. The Puzzle Maker, Uniting the Forces. Enter James Clerk Maxwell, an endlessly curious Scottish prodigy who published his first scientific paper at just 14 years old, and who became completely obsessed with figuring out if these two forces were actually part of the exact same phenomenon.
To crack this, Maxwell did what he did best. He turned to the math. He took decades of scattered, messy experimental data from other scientists and started weaving it all together. And in 1864, he dropped a massive bombshell, a revolutionary paper called A Dynamical Theory of the Electromagnetic Field. This single, brilliant document laid the exact mathematical foundation for what we now celebrate as Maxwell's equations.
There are 4 equations in total, and together they completely changed the game. Let's break them down, starting with puzzle piece number 1, Gauss's law for electricity. Simply put, this equation tells us that electric charges create electric fields. Imagine you take a highly charged balloon and just stick it in the middle of an empty room. That balloon's electric field is going to spread out into space in every single direction. If the charge is positive, it pushes outward. If it's negative, it pulls inward. Pretty straightforward, right?
Now let's grab the second piece, Gauss's law for magnetism. This one shows us exactly how magnets are entirely different beasts than electric charges. See, a negative electric charge can just sit there, totally happy all by itself. But magnets? No way. They refuse to be alone. If you take a standard bar magnet with a north and a south pole and you chop it perfectly in half, you don't magically get an isolated north pole and an isolated south pole. You just get 2 smaller magnets, each with its own north and south. Magnetic monopoles simply do not exist in nature.
Moving on to piece number 3, Faraday's law. Now, this one is incredibly practical. It tells us that a changing magnetic field literally creates electricity. This isn't just some abstract math problem, guys. This is happening all around you. If you've ever cranked one of those emergency flashlights or ridden a bike that has a little dynamo powering the headlight, you are looking at Faraday's law in real time. Moving a magnet generates an electric current. And without this specific law, our modern power stations wouldn't be able to generate a single drop of electricity.
And finally, the fourth piece, the Ampere-Maxwell law. Scientists already kind of knew that an electric current could create a magnetic field. But here is where Maxwell pulls off a stroke of absolute genius. He's looking at the math and he realizes something crucial is missing. So he adds one revolutionary, game-changing concept. A changing electric field also creates a magnetic field. Boom. With that single brilliant tweak, the loop was closed. The greatest puzzle in 19th century science was finally complete. Section 2. The climax, calculating the waves. Now that Maxwell had combined these 4 equations, the math did something absolutely astonishing. It predicted that these interlocking electric and magnetic fields would travel through empty space as invisible waves. Naturally, Maxwell wants to know how fast these brand new waves are traveling, so he sits down, crunches the numbers, and calculates their speed. The answer his equation spit out, approximately 300,000 kilometers per second. Now this was a jaw-dropping moment, because 300,000 kilometers per second wasn't just some random output. It was the exact, experimentally measured speed of light.
The implication of that specific number was easily one of the greatest aha moments in human history. Maxwell suddenly realized that light itself is literally an electromagnetic wave. Think about that for a second. Before this exact moment, electricity, magnetism, and light were treated as three completely different things. Now, he just proved they are all different manifestations of the exact same underlying electromagnetic field. It was the ultimate scientific unification.
But you know, math on a chalkboard is one thing. Actually proving it in the real world is another. Sadly, Maxwell passed away way too young, before he could see his equations physically proven. But fast forward to the 1880s, and a brilliant German physicist named Heinrich Hertz sets up an experiment in his lab. He successfully manages to generate and detect invisible radio waves, confirming Maxwell's math flawlessly. That single moment, that was the birth of wireless communication.
When you zoom out and look at the whole electromagnetic spectrum, the sheer scale of this discovery is staggering. Thanks to Maxwell, we know that all of these things are literally the exact same kind of wave, just buzzing at different frequencies. Down on the low end, you've got radio waves and microwaves, running your TV and heating up your leftovers. Move up the dial, and you hit visible light, the literal colors your eyes are seeing right now. Keep going, and you get X-rays for checking broken bones, and gamma rays used to treat cancer. The whole shebang is just one single phenomenon, perfectly captured by Maxwell's 4 equations.
Section 3. Reverse engineering the modern world. Honestly, it's almost impossible to overstate the immense scale of what Maxwell's unification built for us.
I mean, just think about the sheer volume of technology you rely on every single day. Without Maxwell, literally none of it exists. In communications, say goodbye to smartphones, Wi-Fi, Bluetooth, and satellite internet. In medicine, no MRI scanners, no X-ray machines. In computing, there's no fiber optic cables piping the internet across the ocean. And in engineering, everything from electric motors and giant power generators to those shiny new electric vehicles on the road right now, it all sits squarely on the foundation of Maxwell's equations. He quite literally coded the operating system for modern technology.
And you know what's crazy? Beyond completely revolutionizing physics in 1864, Maxwell was just a ridiculously fascinating guy. A little palate cleanser for you. Did you know that in 1861, he actually produced the world's first permanent color photograph? He used red, green, and blue filters, which, by the way, is exactly how the digital screens we use today work. He even used math to prove that Saturn's rings weren't solid disks, but a massive swarm of tiny floating particles. The guy's curiosity literally had no off switch.
But his absolute greatest legacy? That's definitely the door he kicked wide open for the next generation of geniuses. Remember that portrait hanging in Einstein's office? Well, Maxwell's equations proved that the speed of light is a hard constant in the universe. And that mind-bending fact directly inspired Einstein to ask a profound question. Wait, if light always travels at the exact same speed, what in the world does that mean for space and time? That one question, sparked entirely by Maxwell's work, led straight to Einstein dropping the special theory of relativity in 1905. Maxwell basically proved that the absolute chaos of nature could be beautifully, elegantly unified using math. And that specific approach, hunting down the hidden connections between totally unrelated forces, that's the exact blueprint modern physicists are still using today. Right now, as we speak, scientists are hunting for a theory of everything to finally unite gravity, electromagnetism, and nuclear forces into one neat little package. And that whole quest is entirely inspired by Maxwell's massive success. So James Clerk Maxwell undoubtedly deserves his seat right next to Newton and Einstein as one of the greatest scientific minds we've ever produced. His 4 elegant little equations unleashed the invisible forces that built our entire modern wireless reality. Which brings me to a question for you. If simply unifying electricity, magnetism, and light gave us everything from smartphones to satellite navigation, what on earth do you think the next great physics unification is going to unlock for humanity? Let that sink in for a bit, and keep questioning the world around you.